Alright, so good day. Going to have a new lesson, of course. This will be a continuation of what we have discussed from midterms. Uh, Kasi what we have discussed from there is just a gist of what Newton envisioned us. Wanted to understand the Newton's law of motion. Now, we're going to see some application of it on several occasions. Okay? So this will be the topics that we're going to cover. Alright? First, we have to understand the body diagram. I think this will be further discussed by your teachers, but let's get a bit of a glimpse and then I'm going to show you how it is generally drawn. Okay? Especially the first two examples. The first two cases that we're going to have for you. So these are some of the examples of the body diagram. So this in two bodies. So this is just an example. Then this is another one. Okay. Then here's a really interesting one on a line plane. Then we have this one. Okay. So let's discuss the parts of the body diagram. So let's say we're going to take the simplest diagram that we can have. Say a box standing on flat surface. Okay, so if you are pushing this box, so let's say we're pushing this box, let's try to draw it a bit. Let's say this box has a mass m. Okay, when pushing it on this direction, going to have force, an applied force. That would be the force that's going to cause this box to move. Okay, and then of course, knowing that it's moving against this horizontal surface, there would be a force opposing it. I think we have shown it on a few examples from the last topic that we have discussed. So this will be what? Friction force. Okay. Then next we have, of course, the force caused by acceleration due to gravity. So that would be this one. Weight. Or then I use this one. Okay, so I know the weight is still a force. Regardless, this is just variable, so I just want to keep F for consistent. Then of course, normal force would be the force perpendicular to the surface or to the ground. Okay, so remember the key term, perpendicular. So it must be in 90 degrees to the ground, not necessarily 180 degrees with the weight, okay, or the force caused by the acceleration, but it should be perpendicular to your ground. So there's that. This will be your normal force. Okay, there. Okay, let's check the next definition. We have friction. So I have showed it already. So it's a resistive force. Okay, we have two kinds. So first is static friction. So let's say on a first scenario, you are trying to move the box. So let's say this box has a mass m, and you're pushing this one with a certain amount of force called Fa, and of course it has mass. It has a weight of W and normal force of F sub n. Then let's say there's a static friction that's causing it not to move. Okay, let's say it's static friction, or I'll just say friction, then I'll just specify it on our formula. So what we need is, of course, the summation of the forces on the x-axis, right? I'm going to write it here. That would be applied force, then of course the opposing force, which is minus friction force. Okay, so if it is static, it means that the object is not moving. Okay, so it means the amount that you're applying is equal to the amount of the friction. Ergo, you are not able to move the the object, the massive object. So any applied force lower than the friction, of course, the friction will not push against you. Okay, because there will be times that the answer for this one is a negative value. So if f sub a is less than, of course, f sub f, then f sub a is negative. But it doesn't mean that f sub f is going to push on this direction. It just means that the force it's causing is stronger than the force you are applying. Ergo, you will not be able to move the, what do you call this? The massive object. Alright? So there's that. In the case of the next one, so that will be kinetic friction. Kinetic friction is once you're able to push the object. So let's say this is you. Okay, so you're able to move the object from this place, from this position to this position. Okay, by pushing it, of course. So you're able to cover some distance, but of course we're not going to cover distance yet, so that's for another topic. What I'm meaning to say is you're able to push this particular scenario. So just copy all the lines and put it here. It's still the same, but my point is summation of the forces for this example is not equal to 0. Okay, means if f sub a greater, by the way, this is less than or equal to, so this one should be greater, okay, than f sub f, then summation of f sub x. By the way, this is f sub x, sorry, summation of f sub x is positive. Okay, so this one is positive. There you go. So it means you're able to push the object. You're able to apply a force, making the object to move. Okay, after all, the very elementary definition of force is the act of push or pull, right? So if you're not able to push the object, you're not able to move it. So you're applying a force, but it's not causing anything. This one, it caused something, right? So this is kinetic friction. So this one is static. Okay, then this one, it there. So this is kinetic friction. Okay, so I hope you got that one. So the operation for friction force, very easy. Okay, so by the way, let's write the definition here first. Resistive force. So to calculate for the friction force, you just have to remember this formula, mu multiplied by the normal force. Okay, so if you're lying on a flat surface, that can also be rewritten as like this, but this is the more generalized term. But for horizontally flat with no inclination, you can use this one as well. Okay, so this one is, of course, you already know this one, this is normal force. So this is the coefficient of friction. Okay, coefficient of friction. Okay, and that is divided into 2. So you have mu sub s and mu sub k. Mu, of course, that's a Greek letter, diba? So mu sub s is for the static friction, and then for this one, this is for kinetic. So there will be few things that you're going to notice. First, mu sub s is always greater than mu sub k. Okay, the reasoning behind this is because if you are not able to push the object, then of course the friction is greater, right? If you're going to look for a graph of this one, friction, if this is friction, this vertical, what do you call this? Vertical axis, so it will look like this. You're pushing, so let's say this is applied force. Then the graph represents how, if you are able to move the object or not. So if it's rising, it means that the friction force is still stronger. So it will hit a peak. Then upon reaching the peak, it will start to descend. So I'm going to use a different pen. Then it will look something like this. Okay. So dividing this portion is for the static friction. Okay. So it means that applying a force starting from 0 up to a certain value, upon reaching that, you are still not able to move the object. Pero once you have reached that point, you're going to be able to push the object. Then you're going to notice that you're already pushing it, diba? So it means the coefficient of friction will be lower. Will be, after all, it will be stated on the given, but this is a known fact. Okay, so if you are solving for a certain, let's say, equation, if you are using static friction that has an if you're having a friction with this equation, it will be greater than an equation having kinetic friction, assuming that you have the same object and applying the same force. Okay. Of course, to further understand how we utilize this equation, let's try to solve some problem, shall we? Do that. Take a look. Here. So here's our example. So a 25, our first guided practice problem na. So a 25 kilogram box rests on a horizontal surface. What is the minimum horizontal force that is required to cause the box to begin to slide if the coefficient of static friction is 0.35? So really easy, right? So let's state the given first. Of course, we're going to follow GRESA. So we have a mass, which is 25 kilograms. Then we have coefficient of static friction, which is, what's that again? 0.35. There. Then for our required, that would be the minimum force. So that's force or something. All right. Of course, we're looking for friction force, but I'm going to explain it later. Okay, so let's just place here summation of forces on the x-axis. Okay, so equation would be, of course, summation of forces on the x-axis would be applied force minus friction force. So the consequence would be summation of forces would be greater than or equal to 0. So the minimum value that we need. Okay. So knowing that there's an equality here, we can just assume that what we need is for the applied force to be at least equal or greater than the friction force. So we're going to explain that later. Okay. So for the solution, of course, let's find first the friction force. All right. So friction force, what we have is the coefficient of static friction, so that would be mu sub s multiplied by the normal force. Then of course, since normal force for this one, if you're going to By the way, draw, always draw, all right? So if you're going to draw, so this will be your normal force, this will be your friction, then this will be your weight. Okay, then since normal force is equal to the weight for this example, all right, so this is our mass, we can just write the equation as friction force multiplied by the coefficient of static friction multiplied to, what's the formula of this? mg, right? Mass times acceleration due to gravity. So what would be that? Substitute. So that would be, oops, 0.35 multiplied by, what's our mass? 25 kilograms multiplied by, what's this? 9.8 meter per second square. Correct? There. So what's the answer for this one? Let me just grab my cycle. I wasn't able to open Desmos. So yeah. Let's try to answer that one. By the way, try to answer it as well, so you can verify my answer. Right? The givens are correct, right? 35 and 25. So that would be 0.30 times 9.8 times 25. So our answer 85.75. Correct? 85.75. Then our unit, of course, is in newtons. So you can state it as force. What do you call this in sentence form using this equation? So we need at least 85.75 newtons to be able to push the box there. Or actually this will suffice, but this makes sense as well. Okay, so yeah, let's have another example. Yes, let me try to open that one. I just moved it. Okay, for all we have ample space naman. So let's check the second example. So here, so a 25 kilogram box rests on the floor. Another 25 kilogram box again. Okay, so it is a two-part problem. All right, so the first one is easy. Try to do that. So we have a given of, again, a mass of 25 kilograms. Then we have coefficient of static friction, which is 0.89. Then we have, miraculously, an applied force. Okay, so this will be for the second example, which is 112 newtons. Correct? Then a kinetic friction there, so you can see how it works, of 0.45. Correct? All right. So for our required, that would be, first we have a friction force, then we have, let's specify it na lang on our kinetic friction. Then we have summation of forces on x-axis, because we are asked, right, to, I know we are asked for the acceleration of the system, so that would be a. Okay, but it is implicit that you have to look for, of course, the summation of the forces on the x-axis. So we have several equations too that can be used here. So first we have, of course, this one, which is of course mu sub s multiplied by normal force. Correct? Then we have kinetic friction, which is of course mu sub k times this one. Then we have the acceleration of the system. So this will require you to have a bit of derivation. Okay, so how about we illustrate it first now? There. Then for the second scenario, you will be able to push it. Okay, so for this one, you're going to have a coefficient of static friction. Then you have, of course, applied force. Then you have our normal force. Okay, for this one, it will be the same, but in this case, going to have kinetic friction instead. Correct? Then still Fa. Then of course this is still normal force. Let's write it on this side instead. There you go. So then of course you have an applied force. It's already here. Sorry. Okay, so let's try to show the equation for the acceleration. So summation of forces on the x-axis would be applied force minus friction force. Correct? So in this case, that would be kinetic friction. So we can expand all this, right? So we have a given mass. So what we're trying to aim, since force is mass times acceleration, we want to have acceleration. So all of this should be written in, should have their masses cancelled. After all, we have a mass here. So what we can do is divide both sides by m, right? So cancel m here. So we're going to have A is equal to F over m, right? Then you can take that and wait, let me write this here. Sorry. So we can have more spaces for the derivations. Since F is equal to ma, then just divide both sides by m. So cancel this one. I'm going to have A is equal to F over m. So how would that look like? So this will be the net force, the net acceleration on the x-axis. Let's write it this way first. Okay, so this will be of the applied force minus mass times acceleration of the kinetic friction. Get that? Because all of these are forces, right? Then you can take out m here, so that will become m times applied force minus the acceleration caused by kinetic friction. Correct? Then this will be the same. Then divide both sides by m. So you're going to be able to cancel m, leaving you with the net acceleration on the surface, or of the box on the surface. So that would be acceleration caused by the applied force minus the acceleration caused by the kinetic friction. Okay, so how are we going to execute that? First, let's try to solve for the first one. So I already jumped on the derivation of both, but it's okay. So for the first one, that would be static friction is u sub s multiplied by the normal force. So this will be 0.89. Let me adjust this one. Multiplied by 9.8 meter per second squared, multiplied by what's our mass? 25 kilograms. Okay, let's check the given again if it is correct. 89, 25, 9.8. Okay, what's our answer for this one? Let me grab my trusty cycle again to solve for it. 0.89 times 9.8 times 25. There you go. Our answer would be what? 218.05. 218.05. Of course, the unit is in newtons. Okay, so box that. Just include the, of course, this one, because after all, this is already the answer for the first one. So this is our answer 1. Okay, so for our solution number 2, what we can do is look for the acceleration look for the friction force first, right? We have kinetic friction, right? So we can do that. So let's substitute. So here it is. So this will be our second solution. So that summation of acceleration on the x-axis would be this one. So this is applied force, right? So what's our applied force? 112 newtons. Expand this one to kilogram meter per second squared, so you can cancel out later. Divided by what's our mass? 25, right? kg. Minus what's our acceleration due to kinetic friction. So that would be from this equation, kinetic friction would be mu sub k multiplied by the normal force, correct? And then of course you can take out the normal force here. By the way, this should be g, because normal force, that's acceleration due to gravity, right? So take note of that one. So let's change this. Okay, so what's the basically they're still the same, but so that you can know what you are going to deal with. So I messed that one up. I'm really sorry. Anyway, so to continue, this is the part where it stopped, right? Can you see it here on me changing a to g, because this one is supposed to be mu sub k m sub g, right here, this one. So this will be the equation that you're going to use upon rewriting f is equal to ma, then, or I mean f sub n is equal to mg. Then of course for kinetic friction, this will be the one that you are going to use. So we're going to cancel m because we're dealing with the same mass, right? So this will be the equation that will be left for you to solve. So this will be the equation for that one here. So summation of, the net acceleration would be the applied force divided by its mass, which is already provided to us, then minus, coming from the original equation, which is this, the coefficient of kinetic friction, which is this one. By the way, this is coefficient of kinetic friction there, mu sub k sub or something, that one. So ito yun, mu sub k sub g. Okay, so this is it's still the same, right? I just got the order reverse, but anyway, this is it. So you have the coefficient of kinetic friction, which is from the given there, 0.45 here. Okay, then multiplied by acceleration due to gravity, which is this. So solving that, you will be having 0.07 as your net acceleration. So I hope you can follow it through. So you can start on this part, okay, then going down, okay, then this will be the final answer for the second required. Okay, so I hope you got that one. I'm really sorry again. Okay.